looks like we are good. So we're going to go ahead and get started here. So for any of you guys don't know why you're here, we're going to be talking about how to choose the right hardware for After Effects. So we're going to cover, well, first of all, like a brief introduction of who Puget Systems is if for some reason you don't know who we are. We're going to talk about what hardware matters, both in terms of like After Effects and just general computing as well. We're going to talk about how to make the right choice for like all the important components, things like storage and RAM, CPU and GPU, all the things that actually are going to affect like how effective you can be in After Effects, how quickly you can render things, how smooth your workflow can be. So just kind of set the stage a little bit. I'm going to cover what we want to accomplish. And really our goal is to arm you with knowledge. That's all it is. This isn't a sales pitch. It's just we want to teach you about how After Effects uses hardware, just kind of give you the confidence that you're getting the best system, whether it's from us or you're building your own, or you have to buy it from someone because you have like purchasing agreements or whatever. And really, it's because we feel that you should have an understanding of your tools. Whether it's After Effects itself, or your computer, or a camera, or lights, or any of those, you should have a basic understanding of all of the tools you use every day, so that you can get the most out of them. And one thing I do want to put on here is that this is general information for After Effects. Once you get into like, hey, I'm using After Effects and Premiere Pro, or After Effects and DaVinci Resolve, or anything else, it can start to get really hairy. There's not really a one-size-fits-all. So if you are going to be using multiple applications that you do want good performance on, then definitely we would recommend talking to one of our consultants. They can help you figure out, take a little bit of performance from application A so you get more on application B, and figure out that right balance specifically for you. A couple of other quick notes. There is a Q&A. Someone's already submitted one, but there is a Q&A button down there, so you can put questions in at any point throughout the webinar. If there's something that's very critical that I need to answer immediately, Oscar is on the line as well, and he will let me know, and we'll answer them directly. Otherwise, we'll probably save them more towards the end. There's also a chat there. If you want to chat, go for it. The raise hand probably we won't use too much in this webinar. But yeah, definitely fill in any questions you have throughout the webinar, and we'll get to them at the end. So brief kind of about Puget Systems, if you are not familiar with us. We specialize in high-performance workstations, but really the thing that we emphasize is our consulting and our support. I mean, in the end, a computer is just a box of parts. And anyone can put together a box of parts. And while we do a lot of things that are special for that box of parts, we do a lot of qualification to make sure it's the highest quality parts that are going to be the most reliable. Obviously, we make sure that it's the right thing for what you're doing. We do a lot of special things in terms of like bracing, so that it'll actually survive the UPS or FedEx trip to you. But yeah, it's really the pre-sale and post-sale, because really we're people just like you, we have one T-Rex. And we just want to help you get your work done. And so we don't ever do any like finger pointing or anything like that. So if you have a problem, say in After Effects, you can come to us and we can help you figure it out. Whether it's an Adobe issue, or it's a hardware issue, or it's a Windows issue, we're never going to say like, oh, that's not our problem, go talk to Adobe. I mean, we might rope in Adobe and get them in like a three-way conversation, but we're never going to leave you out in the cold and just leave you to try to figure out how to solve your problem. We're always going to help you find a solution, whether it's a temporary workaround or a permanent fix, and get you up and going as quickly as possible. Because your job is to create, whether it's motion graphics or VFX or just, content in general. Our job is to handle the computer side of it so that you can just get your work done. Let us focus on the hardware. You focus on, being creative and doing what you do. And kind of as a part of all of this process of making it so that you don't have to be a technology expert like us. I mean, some of you probably are, you love technology. Other people, you just want to get your work done. And one of the ways we do that is we kind of segment a lot of our products into what we call solutions. So they're more focused on the software rather than the hardware. So After Effects is a great example. You go to our After Effects page, we have one kind of platform that then you can configure a little bit, but it's really just like, it's all the right stuff just for After Effects. So you can't make a mistake in that way. So you're not being, thrown 1,000 different CPUs from Intel and AMD. You're given, in fact, I think on the After Effects system, it's one. So you're not even allowed to configure the CPU. So there's really only one that's the best choice for most people. Another thing we do is we do a lot of publications. So this is really where my role here as a hardware analyst comes into play, where we look at, Intel launches new CPUs and AMD launches new CPUs, and we look at, okay, how do these new parts actually perform in the real world in After Effects, Premiere Pro, Photoshop. We've got things for rendering and photogrammetry. And how does it actually work in the real world? There's so many reviews out there in terms of hardware. They look at gaming or synthetic benchmarks. They're starting to do better looking at actual real world applications like this, but we're still probably one of the most in-depth and thorough as far as what how do they actually perform. And it turns into a whole bunch of numbers. So if you love numbers, well, you'll love our articles. So this is just from one of our After Effects ones, and it turns into charts and charts and charts and charts. But again, you don't have to go through this if you don't want to. This is more for people who are interested in this, or to back up, what we are telling people. Here's our proof point. Like here, look, you can look at actual numbers. But really, honestly, I would say just talk with our consultants. They understand all of this, and they'll help you get into the exact right thing. And the reason why we do all of this work is because there's really not a one-size-fits-all. That's why we have an After Effects recommendation system, and one for Premiere, and one for DaVinci Resolve. It's because each of these applications use hardware differently in slightly different ways. So this is a very not scientific chart that I threw together a couple months ago, but just to kind of show you that, like, After Effects here on the left, it prioritizes a CPU with really good single-threaded performance. Multi-thread is not a big deal. GPU is not as big of a deal, but you want a lot of RAM, and that's counter to something like Premiere Pro, where like you want a CPU that's actually fairly balanced. GPU is more important. You don't need as much RAM. So again, it comes down to what applications are you using and how do you balance it. And today we're just going to be talking about After Effects in its own little bucket. Okay, so all of that going through, what actually influences performance in After Effects, or really anything else? And I kind of think of it as kind of like this building, like this kind of Pantheon building, where you have all these different parts that all work to hold up the experience of editing, however you want to define experience. And kind of at the bottom here, you have your foundation. You have storage, and you have RAM, or system memory. And really, those are the two things that anytime I'm helping someone configure up a system, or figure out what upgrades they should make or anything like that, you start with these, because these really need to be the foundation of your system. If both of these are not correct or enough for what you're doing, it doesn't matter how fast your CPU is or how fast your GPU is. It just doesn't matter. You need these foundational things set before you move on to, honestly, what is oftentimes the more fun things of like, hey, how fast can I render out this comp? Then you have like these pillars that hold up, the performance side. CPU I mentioned. There's the GPU or video card, which is increasingly important, actually. And I threw together other miscellaneous. We'll talk about a few just other factors that you might want to keep in mind. Some of these don't actually impact performance directly, but it's still like you might end up wanting to spend a little bit less money on the workstation and spend it more on one of these other items, just because it will overall help with your editing experience. Okay, so we're just going to go through those five, and one by one and just talk about them. So storage is probably one of the ones I would start with first. Probably the easiest to relate to. I mean, it's where you put your media, your assets, your project files, your applications, your media and disk cache, all those things, fairly straightforward on the surface. But one of the biggest things to always get across to people when I'm telling them about storage is that storage is not all created equal. You have multiple types of storage. Honestly, you can get into like external storage and NAS. We're mostly going to focus on internal storage in the computer itself. But a lot of this will apply to if you wanted to do external storage as well. And so kind of at the most basic level, you have these Platter hard drives. They've been around forever. They're incredibly affordable. They're massive. You can get 14 terabytes per each drive maximum right now. I've heard that they're going to be doing like 18 terabytes or 20 terabytes in the next year or so. So they're absolutely massive drives. They're fairly quick these days too. About 200 megabytes per second is their transfer speed on most drives. And so that you can use them for some of your assets, but primarily we use them these days for like backup and archiving. So stuff that you don't need access to every day, but you need it sometimes. So you don't want to, take up space on one of your slightly more expensive drives. So you toss it on one of these things, or you use it just for backup of projects. Hopefully you're also backing up to either an external drive or the cloud or a NAS unit or something like that, because you definitely don't want to just have all of your backups on one drive. That's not really even a backup then at that point. But so yeah, these drives, we typically use them for a little bit like midterm storage internally. They're very common on NAS units because they're just great drives for long-term. They're cheap, they're large, and they get the job done. Step up from that, we have SATA SSDs, and these have been around for quite a while now. They're pretty standard at this point. And so these are solid state drives. They are more expensive than platter drives. You can't get them in as large of capacities. About 4 terabytes per drive max is what they're at right now. They're quite a bit faster. So they do about 500 megabytes per second in terms of transfer speed. But the biggest thing is that they're solid state. So a platter drive has spinning media and then a head that's finding the media. And so it takes time to find your data. A solid state drive, it's instant. So you don't have any seat time. That's one of the big things that make a computer feel really snappy. Like even when you're just working in Windows, it's the fact that it's on a solid state drive. Hopefully your computer's on a solid state drive. And so these are kind of jack of all trades drives. They're great for your OS, they're great for your assets, they're great for cache. A lot of people use them for backup drives because they are actually more reliable than platter drives because they don't have any moving parts. They are going to fail less often. And the reliability rate on Samsung drives in particular, I can tell you, is absolutely amazing. They're one of the lowest failing parts in our computers, like hands down. They fail less often than your processor. So they're really amazing. Then you have a step above those, and then you get into these NVMe drives. They come in a bunch of different form factors. There's M.2, that's that one on the top that looks kind of like a stick of gum. There's U.2, there's PCIe, which is kind of similar to like video cards. The biggest thing is that they can be slightly more expensive than a SATA SSD. Some of them are actually about the same price. They're smaller drives though, so only about 2 terabytes per drive max. Most of them are going to be in the 512 gigs to 1 terabyte, but they're incredibly fast. Somewhere around 7 times faster than a solid state SSD. So 3.5 gigabytes per second read on the fastest drive. Some of them are only about a gig a second read only. The main thing with those is that honestly, often your storage speed is not the bottleneck anymore once you get above a SATA SSD. I mean, if you think about you're using like ProRes media, like that's not going to tax an SSD at all. So getting a drive that's 7 times faster, well, it doesn't really matter. You're not bottlenecked anyway. But there are some things where that extra high performance is useful, and that's mostly going to be like cache files. So whether it's your media cache or disk cache in After Effects, it can really help quite a bit. And it's actually not the read performance, it's the write performance, because After Effects writes to the disk cache kind of in the background. So it does it whenever it thinks nothing else is going on. The faster the drive is, the faster it can write to it, the more of those frames it's going to be able to cache onto the drive before it has to focus on actually doing playback or rendering or whatever else you're doing in After Effects. So those are the 3 kinds of drives, different tools for different jobs, and it just depends on which one is right for the different parts of your system. And so next question is kind of what goes where. So okay, we've talked about these 3 drives. How do you actually divide up what's in your system? And I would say there's kind of 3 levels. I'm going to try to stick to a good, better, best throughout most of this webinar. And a good is honestly you just get an SSD and you use it for everything. It's very common in like laptops, a little bit more budget focused machines, and honestly it's pretty solid. It's going to be fairly good for almost everything. So like if you need to, go for it. Just get an SSD, call it a day. It'll be awesome. A better option would be you use either an SSD or an NVMe drive for your OS, application, and project files. So that's going to be like any assets you have, videos, graphics, all that kind of jazz. And then you have a second drive, a dedicated drive, either an SSD or an NVMe for cache. And which one you want to be on NVMe, whether it's worth it for the cost, it kind of just depends. The larger compositions you tend to work with, you might want to prioritize an NVMe for cache because, well, you have more frames that you want to be caching into the disk cache. So yeah, fast drive makes sense. If you don't, if you only work with HD or, you don't have to deal with the disk cache all that much, well, then maybe you prioritize an NVMe for your OS just to make things that slightly bit more snappier, let After Effects, launch a little bit faster. Again, it just comes down to the what the value is for you versus the cost trade-off. Sorry. And then you kind of have this best level. And this is what we tend to try to get our customers into. And this is either an SSD or an NVMe for your OS and applications. We're actually starting to trend towards NVMe's even for your OS, typically slightly lower end NVMe's because you don't need quite as much speed, but still getting them onto an NVMe for your OS and applications. A dedicated SSD for project files, and then an NVMe drive for your cache. And the reason why we don't really push NVMe's for your project files is kind of what I was talking about before, where you really don't need it for the speed. And so having the ability to get a larger drive, up to 4 terabytes is really nice. They are also a little bit more reliable. They have a higher, what's called endurance. So the number of times you can write to the drive. And I mean, they're crazy numbers no matter what, but it's even crazier on just a standard SSD over an NVMe. So being able to be a little bit more confident that your assets and projects are not, are just less likely to have an issue, I suppose, is really nice. It's a nice little bit of comfort there. And then we get often, how big. I'm going to kind of glaze through how big of drives simply because everybody's different. I mean, how large of projects do you work with? How many projects at a time do you work with? But just some rules of thumb, starting points. OS application drive, you probably want at least 512 gigs max. I mean, if you have the entire Adobe suite, you might want more. If you tend to never empty your downloads folder, you might want more. Just all depends. Cache drive, I'd say minimum starting point is 256 gig. Even that, it might be stretching it. You probably want to be more like 512 minimum, but it depends on the length and resolution of your projects. If you only work with HD projects, you probably don't need as much. If you do 4K, you might want a larger drive. And then your project files, again, completely depends. I would start at 512 gig and go up. I think a lot of our customers end up actually at about the 2 terabyte level for their project files. Some go up to 4, some end up with multiple drives. All depends. This is the one thing that honestly a rule of thumb is almost not even a rule of thumb because everybody is different. So that is all everything I've talked about is in terms of internal drives. I do want to touch on external and NAS or SAN units. And the big thing here that we typically are recommending these days is we really encourage trying to get onto like a network attached storage over just like an external drive. External drives absolutely have their place. But if you're talking about, not having to take anything off site, it's all going to stay on site. NAS or SAN units are really nice. They are more expensive to get started, but yeah, they have a lot less issues with like mixed Mac and PC workflows because, well, it doesn't really matter. It's agnostic. Whereas an external drive, if you format it on a Mac, you have to use special software in order to read it on Windows and vice versa. And that special software is fine. One of the ones we recommend often is called Paragon. And it works great for like copying files, but I would never want to actually work off of a drive that is going through one of these like translation applications. It just, sometimes the drive drops, you get all these weird issues, and then After Effects is going to freak out. Usually not a great experience. But if you are going with a NAS unit, a couple of things to keep in mind. You do want to make sure the connectivity is fast enough. So you have a gigabit or 10G is very common these days. You do need to make sure the drive is fast enough as well for what you're doing. But rules of thumb, gigabit should be fine if you are just single user, maybe 2 people. You just access it for every once in a while you have to grab some assets or something. 10G is really if you're getting to multiple users, you're working with like 4K or 8K media directly off of the NAS, or just lots of shared assets. And 10G is fairly standard these days. Most NAS units are going to have it. Our workstations it's standard on some, it's an option on others, and it's not very expensive to get. And if you are looking at NAS units, we have actually recently partnered with LumaForge. It's a fairly loose partnership. It's basically, we've gotten in their NAS units and we've verified it on our workstations. We've sent them some of our workstations. They verified it on their end. And we've talked to each other, figured out how to do like support handoffs if there's an issue with anything. So they're our current go-to like recommendation if you want to look at it. They're a great company. Their support's awesome. If you don't already have something, a company you want to work with, highly recommend looking at LumaForge. Okay, let me check here for a second. Okay, so talk about storage. RAM is the other side of kind of that picture. So system memory, and really it is storage. The only difference is that it's a lot faster and it's temporary. So it's application data is stored in there. So when you launch After Effects, it actually loads After Effects into RAM as well as your projects. In the case of After Effects, it is also where the RAM preview it caches frames to RAM directly, and that's that green bar that's as you play through a comp. That just means it's been cached into RAM preview, and now when you go back and you play again, it doesn't have to re-render each one of those frames. So the more RAM you have, the more frames they can cache, which we'll talk about here in a second. So first of all, question: how much is enough? The answer is it's never enough. Never, 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 ever, really, with After Effects. It mostly just comes down to, okay, when do you start to think, oh, okay, I need to start spending more money on CPU or GPU, or hey, my budget's ran out. Because, yeah, the more RAM you have, the more frames you can play continuously, because once you fill up your RAM, it'll stop playback. I'm sure you've all experienced that. And the more RAM you have, the more frames you can cache into RAM preview. So that means when you go back and you're looping through something to see, how it actually looks, you don't have to re-render those. A fast disk cache can kind of help, because it's supposed to be writing each of those frames also to the disk cache, as long as you have that enabled, which it is by default. And so theoretically, if your system was fast enough, it would write all of those frames to the disk cache, and then you wouldn't care about RAM. But that's unfortunately not really how it works, because After Effects, it does not prioritize writing to the disk cache. It wants to make sure that what you are doing actively in After Effects is where it is dedicating resources to, and then it writes those frames to disk cache kind of in the background whenever there's a chance. So it's a little bit inconsistent in how it works, and that's by design. It's to prioritize, again, what you are actually doing rather than these background tasks. You can use math to guide you to figure out how much RAM you need. It's a fun formula. It's the height of your composition by the width times the number of bits per channel you're working with, and then divided by somewhere around 2 million. I'm actually not sure where that number comes from. It's combining a whole bunch of other math things into one number. And that is per frame. So if you have a higher frame rate composition and you want to be able to play back 10 seconds at a time, well, you're going to need more RAM if it's a 30 FPS count versus a 24 FPS. And so this is one of the charts that we put on our recommended systems for After Effects, to just kind of give people a little bit of help. So it's basically, if it's on the left there is if you're doing a 1080p, so HD comp, or on the right is 4K. You can go through that. Here's a little bit more of a summary, but it's basically, okay, if you want to do a minute worth of compositions at a time, then if you're at 1080p, then you need 32 gigs of RAM, kind of minimum. If you are doing 4K and you still want to be able to do a minute at a time, you need 128 gigs. And that's with 16 bits per channel. If you go up to 32 bits per channel, it's actually just straight up double. If you do only 8 bits per channel, well, then it's actually straight up half. And again, I'm not going to sit on here for too long, but you can go to our recommended system for After Effects. There's a hardware recommendations tab, and this is on there, as well as a lot of what I'm talking about today is actually on that page as well. So primary considerations when it comes to RAM, obviously capacity, talked about that already. Don't really worry about RAM speed. A lot of people on the internet make a big deal about, hey, you need high frequency RAM, or the timings of the RAM and all this other stuff. Honestly, it doesn't make that big of a difference, especially for After Effects. Just make sure you have enough is the biggest deal. And again, good, better, best, 32, 64, 128 is typically what our customers end up with. We have a few customers that go up to 256 and all that, but it gets kind of hairy. The other thing that comes up often is what's called ECC, or registered ECC. And so ECC is error correcting RAM. It's hardware-based error correcting for, you have all these little bits in the RAM and cosmic radiation causes one of them to flip. Then the error correcting will be able to detect that and fix that so you don't get an actual error on the system. It's not as important these days as it used to be. Modern RAM is really reliable now, so it's not as big of a deal. We do still have some customers that go that way, but it's typically just for like mission critical. So think like the person who's doing the live graphics for NFL. Yeah, they probably want to be using registered ECC memory. But just someone, working from home, freelance, even smaller or medium-sized production houses, honestly, we don't push ECC on those customers. The one thing that it does allow you to do, especially with this registered stuff, is that is the only way today to get more than 128 gigs. So if you are working with really large compositions with high resolution, you might want to end up going with registered memory just so you can get more. It's more expensive, but you can get crazy amounts. The problem with that is it requires a Xeon CPU, which we'll talk about CPUs here in a little bit. But you know, little spoiler here, they are more expensive than the CPUs we typically recommend, and they are generally a bit slower in most cases as well. So it's basically you're giving up both cost and speed slightly in order to get just more RAM. And there are times when that makes sense, absolutely. But it all, again, depends on what you're doing. Okay, so we made it about halfway through. We made it through 2 more. So I'm going to take the opportunity to just take a drink, let my voice rest for a second. You can enjoy some kittens. If you're not a kitten person, here's some puppies. And then we'll get going. Okay. Now we're doing on time. We're actually doing not too bad. So getting back into the fun things. So we've got CPU and GPU left, plus the other things. And so CPU, it's really the most important when it comes to straight up performance. So now we're beyond the foundational things where it's more about capacity and getting enough for what you need. Now we're getting into like speed. And After Effects is primarily a CPU driven application. A lot of applications really are still these days. And even the things that are going to use your GPU, it still is using the CPU in some parts. So it's really, really important. It's one of the core components in an After Effects workstation for performance. And excuse my poor artistic skills, but this is kind of how I tend to think of CPUs in general. You have CPUs that are, you know, have a small number of cores, but each one of those is really, really fast. This is a small guy on the left. And then you've got big CPUs with tons of cores, but each one of those cores is slower. It's like just the only way they can work when you're jamming 18 or 32 cores into a single CPU. They have to just be slower each. And right now for After Effects, it's those small, you know, more spunky CPUs really are going to be much better for After Effects. So you don't want to get some giant CPU when it comes to After Effects. You want something that is going to be more quicker, you know, better per core performance. I mean, we talked about this a little bit at the very beginning. It's about per core performance, not having just more cores. And I will put a little caveat on here that this is just until Adobe changes everything. Hardware and software is always evolving. And actually at Adobe Max last week, they showed a little bit of demo of how they were going to be bringing multi-threading back into After Effects. This was a feature that was in After Effects. They took it out in 2015, I believe, the 2015 release. And that was because I don't know if they ever came out and said exactly why they took it out, but my impression was it was because that's when they added GPU acceleration and it had some conflicts there. And that is, and it was also just like problematic, especially with like plugins, it would break oftentimes. And the demo that they showed, it's not even just for exporting anymore. That feature before, it was just for exporting. Now this is actually even for rendering in the timeline. Now, how well this is gonna work, who knows? When it's gonna be available, who knows? It could be in the next update, I highly doubt it. I would say it's more likely to be a feature that's 2 or 3 years out, but you know, it was a very early demo they showed. I couldn't even find anything that they like published afterwards. This was just in one of the sessions that I happened to go to. So yeah, that's more of a be aware kind of a thing rather than a make decisions on your computer today kind of thing. So just kind of keep that in the back of your mind. You know, these days, often the CPUs that we're recommending are already like 8 or 12 or 16 cores. So it's going to give a nice performance bump to everybody. So don't worry about it too much. Don't go buy a dual Xeon workstation or something just because of this. So considerations for your CPU. And we talked about this. More cores is more better. And no, not at all. Except in a few unique circumstances. There are plugins like Render Garden or BG Render Max, I believe it is, that they kind of bring back some of that functionality that got taken out in 2015. So you can do exports and spread it across all the cores on your CPU. But even those, they don't actually scale as well as people think. They think, well, hey, I have an 8-core CPU, it should be 8 times faster. No, not really. It's more like maybe 2 times faster with these things. But yeah, it's oftentimes the frequency, the cache, and just general architecture. You know, these things that are never in the specs for the CPU, never in the marketing materials. Oftentimes, they're more important than straight core count. I mean, you can take 2 CPUs that are the same frequency, same cache, But if they're one generation apart, that's usually about a 10% performance difference. You know, if you're looking 2 generations or 3 generations back, yeah, it might look like, hey, this CPU I bought 5 years ago has the same frequency as the one today. That doesn't mean it's the same performance. It's probably going to be, you know, 50 or 60% faster on a new CPU. So keep that in mind. AMD or Intel is often a question we get. Right now, it's actually very, very, very close. It used to be that Intel dominated because their per core performance was way better than AMD. AMD just kind of like threw cores at the problem. These days, no, AMD is making some really, really great progress. I'd say in terms of like the best options, the fastest options for After Effects, they're pretty interchangeable, and I'll get into specific models here in a second. AMD tends to be a little bit faster on the lower mid-range. So if you're not buying, you know, the top-of-the-line system, you might edge towards AMD a little bit. It's going to be pretty darn close, though. There is one advantage with Intel, and that is you have certified Thunderbolt support on boards that support it. So if you use Thunderbolt drives, then you might want to lean towards Intel just so you can actually get Thunderbolt. AMD pretty much doesn't support it at all, and that's partially because Intel controls Thunderbolt, so they're not going to certify AMD stuff. Yeah, so you might lean a little bit towards Intel. We tend to just a little bit just because of the Thunderbolt, but in general, you're not going to make a bad decision either way. But there are a whole bunch of product lines. You know, Intel has their core 9th gen. They've got their X series. They've got Xeon W and Xeon SP and all this other stuff. AMD, they have a whole bunch too. They've got their Ryzen, Threadripper, and Epic is like their server stuff. But it's mostly the 2 product lines that we tend to focus on is the Intel Core, the 9th gen, and the AMD Ryzen, which is currently 3rd gen. And so those 2 tend to be the 2 that we focus on. The other models, there's much more expensive CPUs from both of those brands, but they are not faster, they are not better for After Effects in particular. So spending more money is not going to get you better performance when it comes to CPUs. I didn't want to do too many charts and graphs. This is just from one of our recent articles. If you want to go to it, you can find it on our site. But I did want to put this on here, not so you look at raw numbers, like go for it if you want to, but mostly to point out kind of how performance levels are with different models. So this i9-9900K is one of those 9th gen Intel CPUs to talk about, and it's pretty much at the top of the stack, even though it's only a $500 CPU. Then right below it, like it's really close, it's going to be percentages, is where you get like the AMD Ryzen 7s and 9s. They're going to sit in there. The Intel X series kind of start a little bit below that. And keep in mind that right now, these are a lot more expensive CPUs, yet they are lower in the performance stack. And then down here is where you get down to the AMD Threadrippers. They're just not the right thing for After Effects. Way down here is where you get to like a 14-core iMac Pro. For whatever reason, After Effects just works better on Windows. It might have to do with actually the video card, which we'll talk about in a little bit, where some of the stuff with NVIDIA in particular is not supported on Mac OS. But just a couple of points here. So the fastest CPU versus the slowest CPU, and I think we're ignoring that old trash can Mac Pro on the very bottom. It's about a 30% difference. So you're not going to be talking about, you know, and this is like just the CPUs we test. We don't go super low on the CPUs that we benchmark for ourselves because our customers tend to want the higher end stuff. So like there's no i3s or Celeron CPUs on here or anything like that. But yeah, between the fastest that we would typically use and the slowest, it's about a 30% difference. So it's small differences, but just to kind of put some things in perspective, the fastest CPU is, like I said, the Intel 9900K, about $500 MSRP. The slowest one is this high-end Threadripper. It's about $1,300. And I don't bring this up to bash on AMD or anything, because honestly, again, like I was talking before, it's about the right tool for the job. And the Threadripper CPUs are just not the right tool for After Effects. They are the right tool for other things, just not for After Effects. So just, yeah, keep that in mind. Spending more money is not the right approach when it comes to applications like After Effects. It's getting the right thing. Okay, so what do we kind of recommend? Kind of at a good level is going to be like a Core i5 from Intel or a Ryzen 5 from AMD. Again, pretty darn close. They both score in our benchmark, which actually you can go and download. I think I have a link at the very end, but you can download and run it on your own system if you want to see how your system performs. But that gets about 900 points. You go up to like a Ryzen 7 3700X. There's actually not really an Intel equivalent at this like price and performance level. So kind of this better. About that, it's about 7 or 8% higher performance. make another jump up again, about another 8% again, and you get up to the 9900K or the 3900X from AMD. And so those are kind of our good, better, best. Basically Core i5 or Ryzen 5, Ryzen 7, and then Core i9 or Ryzen 9. Yeah. Okay. Check here, make sure. Oh, I do see one thing here. Someone mentioned Thunderbolt, where some boards out there do have Thunderbolt on them. Yeah, I think ASRock is one of those, but it's not certified by AMD or Intel. It's like ASRock just said, it'll probably work when they throw it on. So that is not official certified. It might work, but honestly, in our experience, Thunderbolt is very finicky on Windows. So you need to have a really solid support. We typically only ever use Gigabyte for people who want Thunderbolt, and only the ones that have it built on board, because they have like add-on cards and stuff. Most of the time they don't work. It might work for you, maybe you might get lucky, but it comes down to what Thunderbolt devices you're using, what Thunderbolt cards you're using, and the motherboard, and if they don't all line up, it's a bad experience. So I would never recommend trying to get Thunderbolt working on AMD. We've even talked to AMD about it, and they say like, no, don't do that. So, okay, I'm going to try to ignore a lot of stuff. I'll cover most of those questions at the end. I don't want to get distracted because I don't want to go over time here, but I'll cover those at the end. So do note though that AMD and Intel are launching a ton of new CPUs soon. I'm not sure what is publicly announced in terms of launch dates, so I'm just going to avoid any actual dates. But the 3950X is one of the Ryzen CPUs that AMD is launching soon. There's all new Core X10000 series processors are coming out. There's new 3rd gen Threadripper stuff coming out. So a lot of these specifics are probably, well, might change in the next, the coming months. So just check on our website if you want updates for then. The generalities of how After Effects uses the processor is not going to change. It's more the specific models that are available. Okay, so the last category before we get to that, just kind of that other stuff, is video card. And this is becoming increasingly important, honestly. After Effects is adding more and more effects that are GPU accelerated. Same thing for Premiere Pro or DaVinci Resolve or any of those others. One of the big things to know is that you just want to look for this little icon here, kind of the 3 dashes and kind of a play sign. That'll show up under your effects panel, and that indicates that it's going to be able to use the GPU. So if you don't ever use any of those GPU accelerated effects, GPU is not going to matter for you. If you use it, if you use a lot of those, like Illuminatory Color, some of the blurs, I think Glow might be, a bunch of effects that use the GPU. If you use those, the more of them you use, the more important the GPU is. One common misconception we hear is that people think that the GPU is used when you like encode to H.264, because like Media Encoder and Premiere, I'm not sure if After Effects actually says it, it has an option called hardware accelerated, and oftentimes that means GPU accelerated. In the case of Adobe products, that does not mean GPU. That means it's using what's called Intel QuickSync on your CPU, not your GPU. So just keep in mind that, yeah, no, your GPU is not actually going to be used just for like encoding. It's used only for those GPU accelerated effects. And one of the other things to know about GPU is that a fast GPU, oftentimes it can be a big performance bump, but it's going to be just like sitting waiting. So my terrible motion graphics thing here, it's like you have the super fast GPU, and it gets what it's doing really, really fast, gets it done with it, but then it just has to sit around and wait for, the other effects that are being done on the CPU or, the actual displaying of them. It just has to wait. So having a really, really fast GPU, oftentimes that just means it gets to the next stoplight faster, and then it just waits. And it gets to the next stoplight faster, and then it just waits. So you don't need to go crazy on the GPU, even if you do use a ton of GPU accelerated effects. You need enough, but getting, going beyond it isn't going to get you very much. So what to consider? AMD or NVIDIA is a common question, similar to the Intel versus AMD. It's a lot easier of a question, though. It's basically you use NVIDIA. After Effects is way better on NVIDIA. Even the lowest end model from NVIDIA is going to be faster than the best AMD card. I can't get into why. I don't know. It's just, man, it's significant, though. So pretty much, yeah, use NVIDIA. GeForce versus Quadro. So the GeForce is kind of their consumer used to be gaming. Now it's kind of not just gaming, it's content creation as well line. And then Quadro is like the professional workstation kind of stuff. Mostly GeForce is way cheaper, and it is as faster or faster than Quadro. So if you're talking about price performance, 100% GeForce. The thing with Quadro is on the upper end, they do have models that have more VRAM, which usually isn't a factor in After Effects, and they are more reliable. We track about 50% more higher reliability with Quadro versus GeForce. Now, that sounds like a big number, but in reality, both of those are under 1% failure rate. So you're very unlikely to have a problem with either way you go, GeForce or Quadro. It's kind of like what we were talking about before with ECC memory parts, like mission critical systems. Yeah, you might want to go with Quadro because that slightly higher reliability is worth the cost. You know, it's worth the extra, you know, $2,000 to get a Quadro that, you know, has the performance level you need. Quadro does tend to have fewer driver issues as well. That's becoming less important actually because GeForce now has what they call studio drivers, and those studio drivers, they don't launch them as often, so they get more testing. They actually are testing them in applications like Adobe. And they don't get just all of those game optimizations that are constantly being put in their GeForce normal drivers. They just don't do that as often. They still get a lot of those optimizations just at a slightly lower pace, which is nice because then that's less likely for things to break. So the driver thing is actually a less of an issue these days. The other question we get is, well, multiple cards make After Effects faster, and the answer is no. That's pretty much it. No, and pretty much anything Adobe, multiple video cards is not going to make the application faster. It's just the GPU is not being used to the degree that it makes sense. Theoretically, I believe After Effects and Premiere Pro both can use multiple video cards, but man, you'd have to have really old and really slow cards for you to see an impact of having two of them. You know, at that point, you just get one card that'll be cheaper than getting two cards, and it'll just be better. So yeah, just do a single card. Don't worry about multiple. It won't break anything in After Effects. So if you have like DaVinci Resolve you use that does use multiple video cards, it's not going to break After Effects, but it just isn't going to help. Again, a chart here, not to make you read a chart, but more just so you kind of get a couple of ideas. So this is from when NVIDIA launched some new super cards. Those are the dark green ones, and we were looking at performance of those versus AMD as well. And a couple of points here. This test that I'm showing here is a best case scenario. This is what we call our GPU stress. It's essentially, we load on a whole bunch of GPU-based effects and we try to minimize the impact of the CPU. So this is best case what you would see in After Effects. Even the slowest video card, that Vega 64 from the AMD, it's 3 times faster than onboard graphics. So having a video card, incredibly important. Having an expensive video card, a little bit less. So it's about a 30% difference between the slowest actual discrete video card and the fastest. It's about half of that if you're only looking at NVIDIA cards, but there is a very hard line of diminishing returns. You don't have to go all the way up to that top level to get that 30% performance bump. You can get up to, usually a lot of our customers, they end up, I mean, I'll talk about this in the next slide, but like a 2060 Super or so is honestly going to be percentages in the best case to the fastest, most expensive cards you can get. So breaking that down into kind of a good, better, best. Good would be like a 1660 Ti from NVIDIA. It's a very affordable card. In our GPU stress, it gets about a little close to 8% or 8 FPS. Better, I would say this is one of the more typical for like a After Effects system that people are buying from us is going to be a 2060 Super. Not that much more expensive, 100, 120 bucks more MSRP, I believe that is. But you get a nice little performance bump. You get up to 8.7 FPS. And then really, honestly, anything above that is not for After Effects. It's if you are also using Premiere Pro or Resolve, those applications that can take more advantage of the video card. Then you get up into like, you can do a 2080 Super or a 2080 Ti. There's some customers that they'll actually go with what's called the Titan cards, and that's more to get the video card memory, and that's if they are doing like 8K stuff in either Premiere or Resolve, you might want to go with that card. But it's not that much faster in After Effects. Honestly, you probably won't notice it. So for After Effects itself, I would save that money, get like a 2060 Super at the top, and just get more RAM or get a faster CPU or get faster storage, spend that money on other things. So quickly, because I was trying to get this into 45 minutes and might go a few minutes long, kind of the other miscellaneous things that you want to be thinking about that can influence how fast or how efficiently you can work. You know, things like, I mean, it could be anything. It could be your chairs. It can be how much coffee, you know, do you need a coffee machine right next to your computer? Do you need a Red Bull cooler? But the three that we kind of tend to talk to our customers about First is a video monitoring card. We typically use deck links from Blackmagic. And what those do, if you're not familiar with them, is they can provide an unaltered video signal to your display. So a secondary display, not your primary. And it gives you the best quality video. It's also the only way to get 10-bit display out in After Effects. And Premiere Pro, you can go through your video card for 10-bit. In After Effects, you have to use one of these cards. And I do want to clarify that that is not working with 10-bit, whether it's footage or compositions. No, you can go up to 16-bit or 32-bit and work with it. This is about just actually displaying it on a reference display. High quality monitors, of course, you always want to be thinking about that. Just to give a couple of names for people who are not sure where to start. We really like Benk. They're great. I don't even know if I'd really call them a budget at that point, but they're great affordable monitors. Azo is also great. They're a step up from that. You can go really crazy. You can get into Flanders Scientifics and all these other ones that are absolutely nuts. But that's just to get you kind of thinking about that. And then also USB DACs. This is something we are starting to push even more on our customers. I mean, if you don't really do much with audio, I mean, don't worry about it. Just use the onboard audio on your motherboard. But we are seeing more instances where people have really nice headphones or speakers, and you can actually get electrical noise if you're using onboard audio or even like PCIe sound cards. Well, you'll get like a jitters or a little hum, and that's just from everything that's inside the computer. You get a little bit of interference between different things. And switching to a USB DAC, that's an external device, preferably powered even from an external, like a wall socket rather than powered through USB. It eliminates a lot of those problems. So we are starting to push people towards USB DACs more and more for anyone that's doing any work with audio. Okay, so that is all the raw content. Only 1 minute over, so that's not too bad for me. Again, remember we do have that Q&A. I see a couple are in there already. We'll go ahead and just try to answer all of those. But I'm not sure if we ended up doing a poll. On some of the previous ones, we've done a poll, but if a poll does pop up, really encourage you to fill that out. It helps us just like tailor these webinars for people to make sure it's exactly the right thing for what you are expecting and wanting. But while people are putting in any questions, just a very quick summary. Storage and RAM really should be your first concern, especially RAM for After Effects. CPU is most important in terms of performance, but man, really, really more money is not faster. I mean, you can spend thousands of dollars on a CPU and it's going to be slower than a $500 CPU. So it's about the right tool for the job, not the most expensive tool. GPU is becoming more important. You don't need much today. Again, like a mid-range is great. This is one of the places that you might want to future-proof a little bit more because GPU acceleration is going to be picking up more and more steam as time goes on. So you might want to go a step up if you can than what you really need just to get that future-proof. But today, not as big of a deal. And of course, don't neglect your display, your audio, other devices, your coffee. I mentioned that already. We're near Seattle, so coffee is a big deal here. Don't neglect all those other things. Your computer is just one tool in kind of your tool belt. You have all of these other things that are going to impact how effectively and efficiently you can work. And of course, we're here to help. I mean, a lot of our customers are like technology enthusiasts even. They love this stuff, but they need to focus on their work. They need to just dial in on what they are supposed to be getting done, working for their clients and getting their work done. So absolutely, we're here to help. Leave the hardware to us, leave the computer to us. We'll take care of all of that, and and you can just focus on your work and what you want to actually get done. Okay, so with that, I'll leave you with a few links. Again, we do have our solutions for After Effects. If you want to get into that, there is a hardware recommendations tab on there as well that covers a lot of the same stuff I covered actually in this webinar, just in text format. You can get to that through pugetsystems.com/go/After Effects or go through our navigation. We do have an After Effects benchmark as well if you want to run it on your own system and see how it compares to the latest hardware. So what we publish in our publications, you can actually run it on your computer and see exactly how much faster a new system would be. It's great for that. It's free version. Right now it's not going to cost you anything. Go for it. It is beta, so hopefully it doesn't break. It won't hurt your system, but it might crash. And if you want to contact us, this phone and email, we absolutely love talking with people. Our consultants are not on like sales commission or anything like that, so they're not going to push you into, you know, buying anything that you're not ready for or that you don't want. It's really about, again, I've said this many times, but it's helping you get your work done rather than trying to nickel and dime. Okay, so we're going to go ahead and go through these questions. And yeah, if you came on this webinar, absolutely thanks. I love teaching these kind of things and being able to give people knowledge, so absolutely thank you for attending. We will have a recording of this that we'll be sending out, I believe, afterwards, or on the same registration page. You should be able to access it. And yeah, thank you very much for coming in here. And I'm going to go ahead and take the time. We don't have too many questions, so I'm just going to take the time and answer all of them, honestly. So we'll just go straight through. Okay. Let's see. Let me go through these. Oh man, first question is a long question. So what chip or CPU is best for both Premiere, After Effects, and graphics applications like Blender, Maya, Cinema 4D, and CAD and CAM? Oh man. That's probably too involved of a question for this. I mean, that getting through all of that stuff, you know, once you start mixing applications, man, it gets into being very, very, very messy. And it oftentimes depends on, well, okay, you listed like 6 applications there. Which ones are the most important? Which ones are you okay giving a little bit of performance up to get on other ones? I would say if you're not building your own computer, honestly, talk with one of our customers. It's probably today, just like throwing something out there, not knowing, again, like your priorities, probably going to be like an Intel X series CPU. But again, there's a lot of stuff coming, and that might change when those things launch. Recommendations as far as workflow for After Effects and Premiere Pro using NAS drives and monitors and connection types for 4K and higher projects. I would lean towards NAS, especially if you're talking about like multiple people accessing at the same time. External drives, they're great for very specific things, transferring offsite or transferring between 2 computers, people who aren't like actually working together all the time. But I would definitely go NAS for most of that stuff. Again, LumaForge is great. Workflows between After Effects and Premiere Pro. I mean, you have the ideal, which is like dynamic link, doesn't always work. The motion graphics templates seem to be much better, so you could go that route. Honestly, a lot of our customers still just end up, you know, they work in After Effects and they just export or they render it out to a file, like a ProRes file, that then they just bring into Premiere Pro. Oftentimes that's the best way. It just depends on how much you need to be able to adjust those things afterwards. Like, are you going to have to go back and make tweaks? And can you spend the time and set up a motion graphics template and use that way instead? So hopefully that at least gets you going there. Okay. Would a Quadro RTX 5000 be beneficial in After Effects? I mean, it worked fine. In general, an RTX 5000, I believe, is roughly equivalent to a GeForce 2070. And I know it's a lot more expensive. So really what you're getting out of that Quadro RTX 5000 is not performance. What you're getting is that slightly higher reliability. And that's really it at that Quadro RTX 5000 level, because I believe that's maybe that is a 16 gig card, might be 8 only. But VRAM in After Effects, you need probably like 8 gigs, and then after that, it's not as big of a deal. So you can go Quadro RTX. We typically only do that for the people that need maximum uptime, maximum reliability. I would say probably 95, maybe even 90, you know, maybe even 99% of our After Effects customers, they just go with GeForce because then they can spend that money on things like faster storage or on faster CPUs. It's just typically, for most people, not worth that much higher of a cost for that small amount of reliability. I mean, RTX 5000 isn't quite at that point, but if you're talking like an RTX 6000, man, you could almost just get 2 computers using GeForce, and then, hey, if one breaks, you just have a whole nother computer. So typically, that's not the way we would go, but it can be beneficial if you need maximum uptime. Dedicated After Effects render machine and best configuration for that. So I didn't touch on this. Well, I guess I kind of mentioned those plugins like AE Render and BG Renderer Max. So it depends. If you're doing a render server, you can absolutely do that. It depends on if you are just sending a single project over there and it's just rendering it like normal, or if you're sending it with one of those applications that's going to split it up across multiple cores. The best CPU for that, because so I didn't want to get too much into this because it's a really big topic, because if you are sending it off to an external server and you are splitting it up, you actually need more RAM, more video card memory, even on the video card, in order to handle that. Because, you know, if you're spinning up 4 instances of After Effects essentially to get 4 times rendering speed, you need 4 times the RAM. You need 4 times the video memory, because it's actually spinning up multiple instances. So that would be one of those cases where you might actually need to go with one of those quadros to get the higher end or the more video memory. But as far as like CPU goes, typically the Intel X series today are the best for that. It's not going to be massive. In most of the testing we do, we see, I think it's like well, I guess it's not too bad. It's like a 50% performance bump going from like an Intel Core i9-9900K, which is our go-to CPU for like After Effects, you know, working on, versus the highest end X series, which is like a 9980XE. It's about a 50% performance bump, but it's like 2 or 3 times the cost. So it depends on whether that's worth it for you. And that is like the CPU cost. The total system cost is not going to be 2 or 3 times, but it is going to be probably like another 500 or so, $500 or $1,000, I think, for that 50% performance bump, which honestly isn't too bad of a trade-off. Biggest thing there is making sure that the software you're going to be using is going to be able to split that stuff up, or if you're, you know, doing your own homebrew scripts using a render. So hopefully that answered that to your enough. What about the new i9-9900KS? Is it worth the difference over the 9900K? So for those that don't follow CPUs super closely, Intel has this 9900KS. It's a short run CPU. It's not going to be available forever, and it's basically, honestly, it's basically an overclocked 9900K. It just actually includes, I think it includes a warranty, and it's, you know, more certified from Intel, so it's been better. We haven't done much with it because it is going to be a short-term CPU. It's not going to be around for a long time, so we don't want to carry something that, you know, we can get, you know, 50 of and then never again. I don't know if it's really worth it. If I had to come up with a number of how much faster it would be, I'd probably guess you're talking about like a 5%, maybe 10% performance bump, which, you know, if you're talking about, you know, playback, you know, if you're hitting 20 FPS with a 9900K, that's going to be like 21 or 22 FPS with the 9900KS. Whether that's worth it for you, but that's up to you. I mean, you're going to need better cooling. The motherboard, you're going to want to make sure it is a nice high quality motherboard, because it's going to be pushing it to the limits. But if it's worth it for you, I mean, go for it. It's not something we're going to offer, again, because availability is going to be very spotty and limited, but you could use it. Is the VRAM a criteria to choose the graphics card type or level? Titan RTX have 24 gig, 2080 Supers have only 8 gig. It can be, again, but it's mostly going to be for those people, someone who's talked about the render server. In those cases, yes, it can be. For After Effects in general, now, once you get up to 8 gigs, like, you're going to be able to do 4K comps, no problem, with 8 gigs of VRAM, even if you load it up with a ton of GP-based effects. Usually going above 8 gigs, we only really worry about for customers that are doing work with like 8K video, whether it's in Premiere, or you could do it in After Effects or DaVinci Resolve. In those cases, with Adobe applications, I believe we typically say if you're doing 8K, you want, I think it's 12 gigs or something. Like the 2080 Ti is probably fine for most people. But yeah, then you could go up to the Titan RTX. Titan RTX is a great card if you are doing, that like BG Render Max or Render Garden stuff to split up your renders, because then you have all of that extra room. It's not the performance of the card, it's only for that thing. But if you are only just doing, you know, straight in After Effects, you're just, you know, render, or, you know, doing RAM preview and then rendering straight through After Effects or Media Encoder, it's just not necessary. It's kind of like storage in general. Like, do you need a 2 terabyte drive? Well, are you going to fill it? If you only have, you know, 500 gigs worth of files, no, you don't need a 2 terabyte drive. It's just empty space that's sitting there. Same thing with VRAM. So in general for After Effects, nah, as long as you have 8 gigs, it's going to be fine. It's only specialty stuff where you really need more than that. So that was all the questions. I do see that there was some chat here, so I'm going to go through those real quick. Someone asked about our solutions pages. Yes, those parts that we list as like default is kind of recommendations. Sometimes They're kind of the bare bones recommendation, so it's not actually what a lot of our customers end up going with. But basically, you can think of our solutions pages as you can't make a mistake for that one application. So anything you select on there will be fine. It's just, it can still be hard to find the right balance between things. That's why even if you do submit a quote on those pages, you still will get contacted from our consultants, because honestly, it's pretty rare that someone configures a system and then does not make a change once they talk with our consultants, because there's just so many factors to think about, and there's no way we could communicate all of those factors on a web page. So we really encourage, or we really push people to just talk to us. A 30-minute phone call or 15-minute phone call is going to get you into the exact right thing for you, and there's no way we can do that off of a impersonal web page. Someone talked about release dates. I'm not going to comment on those because I don't know what's actual official public. Which DAC do we recommend? Honestly, we have a couple that we have on our configure pages, but those are more like great entry level options. It's kind of the way we handle peripherals in general, where like, okay, you're not sure what you need. Here's great like options that are solid. DACs are a whole crazy thing. Honestly, that's not my specialty, so I wouldn't really want to tell you what brands or anything to go with. The one thing I can tell you, because you mentioned you still hear interference, is that we actually have seen that with our DACs too. And it turned out to be a grounding issue with some speakers or monitors. And how we fixed it on ours was to make sure that we were powering our DACs through a wall socket. So like, most of them just use like little like USB powers. And so we're actually starting to bundle those powers with the DACs that we sell, even though it's a couple bucks to us, but it removes those issues. So definitely look into seeing if your USB or if your DAC can be powered externally. And if you can, try that. That has solved the issue for some of our customers. Okay, and I think we made it through everybody. So again, thanks everybody who stuck on and stuck around for the full hour. And yeah, we'll have a recording that we'll be sending out in the coming days. You'll be able to send that to any coworkers or IT staff or whatever. They'll also be able to access it directly if you go to the same registration page. We're going to swap that around, and it'll go from a registration into a here's the link to the recording. So again, thank you very much for everyone who attended, and yeah, everyone have a great day, and have fun configuring After Effects computers.